Very good evening. I am Bhanu Prakash Lohani. I am research scholar from School of Computing Science and Engineering, Galkotia University, India. My topic of presentation is Synergistic Ensemble Classification Framework utilizing the soft voting algorithm for enhanced prediction and diagnosis of diabetes mellitus. My presentation outlines consist of the following. Number one, abstract. Number two, introduction. Number three, objective. Number four, proposed methodology. Number five, data description and distribution. Number six, result. Number seven, conclusion. And number eight, the references used in the paper. So basically, I'm starting with the abstract. So as this topic is related to diabetes mellitus classification and detection. So the research provides a comprehensive assessment of three ensemble machine learning model, stacking, soft voting, and hard voting, basically focused on enhancing diabetes diagnosis among Pima Indian women dataset, which is taken from National Institute of Diabetes and Digestive and Kidney Disease. Basically, this study focuses on Pima Indian women aged 21 and older, with the dataset comprising critical diagnostic measurement. Two ensemble models were developed and evaluated on the various evaluation parameters like accuracy, precision, sensitivity, F1 score. ROC curve is also drawn. The stacking model integrates various classifiers prediction using a meta-classifier for the final decision making, thereby which is leveraging the individual strength of different models. So next, as per my presentation, the introduction part. So in this introduction part, basically I will focus why diabetes mellitus is too important and why we have done work using machine learning and how machine learning models provides better solution and for the early prediction and diagnosis of diabetes. So basically diabetes mellitus, which is a global health crisis, diabetes is marked by elevated blood glucose level and possesses a particularly severe risk to certain ethnic groups, including Pima Indian women. Timely detection and management of diabetes is very essential for reducing its long-term complications. Machine learning models and the algorithms have become an invaluable tool for improving the early prediction and diagnosis of diabetes, providing a major advancement over the traditional approaches. The potential of machine learning in medical diagnosis is obvious with the use of ensemble learning model, which harnesses the strength of multiple algorithms to enhance the predictive accuracy. The objective of this paper includes the following, which are for the performance and to enhance the model. The following objectives are outlined as follows. An ensemble model was developed that integrates random forest, logical regression, NAP-based, and the other algorithm using a voting and stacking ensemble classifier. This model is designed to categorize the used dataset into two categories, which is positive and negative. Positive means the person which is having the measures is diabetic, and the negative means that is not diabetic. The precision, recall, F1 score, accuracy, and the area under the curve, AUC, as our primary matrices to evaluate the effectiveness of our proposed model. The proposed ensemble model outcomes exhibits enhanced performance when benchmarked against the existing model while maintaining the defined parameter. The assessment of our approach includes a rigorous comparison with the standard Bayes classifier, which includes logistic regression, random forest, naive-Bayes classifier, gradient boosting classifier, XGBoost classifier, AdaBoost classifier, and CatBoost classifier, which demonstrates the robustness of the proposed model. After this objective, the proposed methodology has been shown over here. Here you can see that we have done at the very first level the diabetes data collection from, as already discussed, from the which is used for Pima India dataset. Then the exploratory data analysis and pre-processing has been done with the help of data normalization and data splitting, standardization, various measures has been used. Then for data splitting, why this data splitting is required? Because in machine learning model, training and testing plays very important role. So we have split that data into two parts, that is in the ratio of 80:20. 80% for the training data set and 20% that is the test data set. Then the model building exercise has been done. So here we have used various models, and what are the various model used for stacking the algorithm? That is the linear decremental analysis, logistic regression, AdaBoost classifier, gradient boosting classifier, random forest classifier, extra tree classifier, li- gradient boosting algorithm, naive-Bayes algorithm, boost algorithm, then XGBoost algorithm, KNN, K nearest neighbor algorithm, decision tree algorithm. Then hyperparameter tuning has been performed with k-fold cross validation, where the value of k is 10. We have also done the feature importance, where the features are prioritized as per the importance of the features. So this is done by the help of the heat map. Then the model evaluation has been done and the performance evaluation of the various matrices has been done, where the performance matrices includes accuracy, AUC, area under curve, precision, recall, F1 score, then other various measures which has been used in this paper. And the final outcome is the diabetes classification and prediction, which is effectively provides the result. Then this is the description of the data set, that what actually the data and what are the various features, how many individual have been there, and what is the outcome, and what are the various values of outcome in terms of whether the values are positive or negative. So in the data description, the data set for the diagnosis of diabetes is taken from National Institute of Diabetes and Digestive and Kidney Disease. It basically encompasses a selection of diagnostic measurement of the female patient of Pima Indian dataset aged 21 year and older. This dataset includes age features and one outcome. Out of 768 individual in the dataset, 268 are marked with the outcome 1, which denotes that the diabetes diagnosis, while the rest are labeled at 0, indicating that no diabetes. So in the next PPT, we have given the distribution of the data with respect to the various features available in this data. As we have discussed that in this data, there are 8 features and one is the outcome. 8 feature includes various features like BMI, then sex, then pedigree function, diabetes pedigree function. So here you can see that the data distribution and how the data distribution is there. There are 2 colors used in this. The red color represent the outcome 0 and the green color represent the outcome 1. The first feature of this data includes the pregnancy feature. Here you can see the count that how the outcome related to the pregnancy. Then the second one is the blood pressure, which is the range is given, and based upon that, the number of people, and then the outcome. The next one is insulin taken by the person, then the outcome again by the same color. Then the next feature is diabetes pedigree function. The next feature is glucose. Then skin thickness function is there. Then BMI, body mass index, and the last is age. As we have done the feature importance, so for feature importance, by the help of heat map, we have done the correlation, that which feature is more correlated. So for correlating, you can see by the help of this, some features are very important and some feature we can neglect some feature. So out of these 8 features, we have taken 5 most used feature having the higher correlation. So here you can see by the help of this heat map, we have drawn the correlation analysis. After this correlation analysis, in the result part, we have done the comparison of various machine learning models, in which includes linear decremental analysis, logistic regression, ADA boost classifier, gradient boosting classifier, random forest classifier, decision tree, light gradient boosting classifier, then nap based classifier, cat boost classifier, XG boost classifier, k nearest neighbor classifier, decision tree, voting classifier, stacking classifier. So basically, as per the objective of our paper, we are focusing on voting classifier and stacking classifier. So various performance matrices has been used. The performance matrices are includes accuracy, area under curve, recall, precision, F1 score, kappa, and other parameters. So here you can see the various comparison we have done, and the voting classifier and stacking classifier basically focus here, where the area under curve shows that these classifier provides the better thing, better result in terms of the AUC, accuracy, and other. So we have chosen the voting and stacking classifier for the diabetes prediction. Here, by the help of receivers output ROC curve, characteristic comparison has been done. Then logistic regression, XG boost, random forest, ADA boost, and voting and stacking classifier. So here you can see out of these classifier, the two classifiers whatever chosen by us, that the voting ensemble classifier. Why we have done this ensemble? Because ensemble provides the better thing, where we are ensembling various classifier into one, and then it is providing the improved version of this. So AUC is this. Here you can see with respect the true positive and false positive, the colors represent here the area under curve and the what is the AUC. So the better AUC has been retrieved by voting ensemble classifier, that is 0.95 in 95%. Then with respect to that, the threshold analysis has been done. The threshold plot for stacking classifier, you can see where the various accuracy measures in terms of the threshold value 0.19 and in the second one 0.30, you just see the precision is represented by a different color. The recall is different color than the various things where the voting and stacking classifiers are basically focused, and the ensemble models using the voting provides the better thing. So basically, what is the conclusion of this research work is basically this research work has been showcased the powerful effectiveness of the ensemble machine learning models in the early detection and diagnosis for the diabetes mellitus, specifically with the Pima Indian female population or meticulous evaluation of the several ensemble models, including stacking and voting on a rich dataset from National Institute of Diabetes and Digestive and Kidney Disease. This has yields the significant insight. Among the model assessed, the voting classifier, which combines the probability estimates from the various algorithms. That's why we have used this voting classifier and the ensemble, because this is combining the probability estimates from the various algorithms emerged as the superior model regarding ROC AUC, highlights its robustness in predicting the diabetes. So what is the future scope of this paper is, as we have used this paper and this research work right now only for Pima India female data set from National Institute of Diabetes and Digestive Kidney Disease. We can also use these models in the future or other disease like thyroid, like Parkinson's disease and other disease, so that it can provide the better result in terms of into the physician, so that the people can get the get free from the risk of having various disease. So this is the conclusion, and these are the reference papers I have used for the literature review of this paper and selecting that why there is the requirement of ensemble model and how the ensemble models are providing a better result with respect to the classical model. So these are the research papers. And thank you. Thanks for giving me the chance to present the paper. Thank you.